taught at Big Precalculus lesson. This is unit 1, lesson 6 on transformations in graphic functions. Yes. So, new kind of video today because I was using this. Well, not going to show it, but it just, I was about to be tired of that. I made a 30-minute video and then a 45-minute video didn't save because it was out of storage. And so I'm going to try to use this instead today, which is PowerPoint, because apparently I can draw in here. And the thing I'm recording on is a computer this time, and I'll just try to use my finger. So let's see. No, I really don't know how to use PowerPoint that much. I usually use Google Slides. I know how to use Google things better. And I knew how to use Microsoft Word in like class notebook, because that's what I was using. But I didn't really know how to use PowerPoint. So that's why the slideshow is really basic. Maybe I can do better. And I might not use this forever, but I couldn't really use class notebook anymore. And hopefully this works, but I've had to change my kind of video for a long time. And on this one, you can actually see me on a camera thing, but I have a hat on because I don't usually wear this hat, but I just have it on because I don't know, whatever. And I have a background on here. I'm using Zoom screen recording because that's the only thing I know that's free. So there we go. Let's actually do this video. So the different transformations that there are, you probably learned this before. So, okay, already I'm not doing. Let me try this. Okay, so y equals a, and then b, and then there's x plus or minus c, and then plus or minus d outside of parentheses. That is your standard transformation form. So standard. It's going to be messy handwriting as long as I'm writing with my finger because the stylus doesn't work. That's my opinion. And so the different things that you have here, B is A, B, C, and D. And based on what things there are, it will change how the graph looks. So if there's a negative A, so if that thing's negative, then it makes it a reflection over the x-axis. And this example right here, I can't undo one here, can I? Was trying to do Control Z. There. And then I have to go back. So that's our square root function, and if we had a negative A, that's what would happen. It goes, this is the x-axis, and if there's a reflection over it, that's what it would look like. If A is greater than 1, then there's a vertical stretch. And a vertical stretch, when it's a stretch, it kind of makes it look thinner, sort of, and or like narrower. But when it's a compression, it gets wider. And that might be a little bit confusing for some people because you think compressed small, but it's actually opposite of what you might think. And then if A is in between 0 and 1, meaning it's a fraction, then it's a vertical compression. So this will make more sense in a second. But then B and C. Now, B and C, there's something special about that. It's when those things change, it's opposite of what you might think. So, opposite of what you might think. So, if B is negative, then you have a reflection over the y-axis. That's what this red thing is. And so instead of like that, it's like that. I don't know if that's mirrored, right, or whatever. And if they were both negative and then B, then it would just be reflect over both, and that would make it in the other quadrant across from it. But if B is greater than 1, I made these things in red here for B and C because it's a horizontal compression, even though you might think stretch, because A greater than 1 is a stretch, but no, it's backwards. So remember that. And B, when it's in between 0 and 1, then that's when there's a stretch. If C is positive, then that means left. You might think that would be right, but it's actually left. And if C is negative, right. If D is positive, up. If D is negative, down. And so basically, if something's inside the parentheses, that means that it affects the graph horizontally, and it can make it go left to right. But if it's outside the parentheses, it affects something vertically, and it can go up or down. So let's see how this comes into play. Next slide. Oh, actually, sorry, back. We're going to see what transformations there are for this, what we have right there. Okay, so this, something important to know is what the parent function would be. This would be a line. So y equals x is the parent function. And we have different transformations here. It's a little bit easier for me to do things when I was on my class notebook thing. So I don't know if I'll keep doing this, but we'll see. So we have a -4, we have just a negative, another -4, and a 3. But a negative is another thing. So even though I circled 4 things, the -4, we look at the negative and 4 separate. So the negative, that's this, the first one that you see, it is if A was negative, and that means reflection over x-axis. So I'll just say R over x-axis. Then the 4, that's if A was greater than 1. It's right here. That means vertical stretch of 4. Sometimes you say by a factor of. I'll just say this is making me write big because I'm writing. The next negative, that's if B was negative, and that means reflection over x-axis. Or sorry, y, not x. Then the -4, that's if C was negative, which means right. So right 4. Then the +3, that's if B was positive, so up 3. So these are the things, these are our transformations, and those are the things that change how the original graph looks. So the original graph, we know what a line looks like. That's what it usually looks like. But we have to do these 5 things to see what it would look like, and that's what we're about to do. But just to show you, if it reflected over the x-axis, then it would end up like this. Then if it reflected over the y-axis, it would be the same as it already was. And then you have to vertical stretch. Can't really show that, but that would make it narrower technically. But then we go right 4, up 3. So our original point is going to be now here. And that would mean our graph looks like that. So that's what it would be like. So there you go. Now we have a graphing problem. This one's a little bit more complicated than the line one, but these are the things that we do. We put it in standard transformation form, which I'll show you how to do. Then you find the transformations, then you find the intercepts, and then you graph. So to put it in the standard transformation form, we need to put our constant, which is -3, on the other side. And this is fine, but this part's not fine because x has to be by itself. So this 2 is going to need to factor out, and also the x comes first. It's don't want the 3 first. So this now changes to g of x. Now I'm trying to run with the mouse. Hopefully this takes, I don't know, this takes a little bit longer, but maybe it's better to do. So now if we divide out this 2. That's what we need to do, which, I mean, really that's factoring out. So then that would put us our 2 to the side, and then that would make us have x plus 3 halves. That takes a long time to write. I was trying to see at first if I could write with my tablet and it would show up on here because I can write way faster stylus, but that doesn't work. So then our -3, that's the constant that I circled, it goes on the other side. That's what I have to do. Now let's look at what transformations we have. So let me change my color green, and I will circle the different ones that there are. There's that, this, and this. Now, our standard transformation form, what is that for this one? Well, we see a square root, so that means that y equals square root of x. That's what our original function was. So our transformations, the first one, that would be a negative, and it's outside of the radical, so that means that it is for a, and if a is negative, we have a reflection over x-axis. Over x. I'll just say xa to save time. Then the next one is 2. The 2 that's right beside that negative, that would be, since it's greater than 1 and less than 0, I mean, since it's greater than 1, that would mean that that's a vertical stretch of 2. Now the 2 inside, you might say, oh, horizontal stretch. Remember, I said that was opposite of what you think. So actually, it's a horizontal compression, but you still say of 2, or sorry, of 1. You say 1/2 because compressions are always. That's gonna take a long time to write. But compressions always are a fraction, and vice versa with that the stretches are always whole numbers. So if this happened to be a horizontal stretch, even if it was a fraction, you make it a whole number. Then we have the plus 3 halves. That's opposite of what you might think. It's actually left, not right. 3 halves. Once you get the hang of it, it won't be the opposite of what you think. But it might be at first. That 3 is outside of the parentheses, so it means down 3. So these are our transformations. Now our intercepts. Well, how do you find? Well, let's think about this. Let me try to just box this off for a second. So our y-intercept is always try to write this. It always has an x value of 0, and then there's a y value that's not 0. Well, yeah, unless it was 0, 0, it would be an x and y intercept. But our x-intercept always has y value of 0. So that would be, we have our x value and then 0. So that, what that means is that we have to set y equal to 0 to find the x-intercept, and we have to set x equals 0 to find our y-intercept. So it's going to take a lot of time for me to solve this, but we should know by now how to do that. So we only in this case will look for our y-intercept. You may want to find your x-intercept too. This is just to help you know where to plot points. So let's set x equal to 0. So if we do that, hang on a second, gotta get my calculator. Okay. this is my calculator that I use usually. Well, technically, you're supposed to do this in your head. I forgot about that. Because you can't always use calculators in Precalculus. So let's do this in our head. I can do that easily. 3 minus 2 times 0. 2 times 0 is 0. So 3 plus 0 is 0. I didn't mean to say minus. So square root of 3 is not something I can do in my head, but if you want the exact number, then the y-intercept is 2 square roots of 3 minus 3. Because we would end up with that, and then this. Put that on the other side. So that means that our y-intercept is 0, 2 square roots of 3 minus 3. And the square root of 3, we know that is likely pretty close to 2, and 2 minus 3 is -1. So let's just say it's around -1. So let's just plot this point. How do we know that? Oh wait, sorry. You have to multiply that by 2. So negative. Let me just start. So how do we know? In case you didn't remember, the square root of 3. How do we know what that is? We don't know what it exactly is, but if we can't use a calculator, but if we know that square root of 1 is 1 and square root of 4 is 2, we know it has to be between 1 and 2, and it's closer to 2. I already know off the top of my head that square root of 2 is 1.41, so it's more than 1.41. This is square root of 3. So let's just say if it happened to be, I don't know. We can just round to 2, about 2. So 2 times 2 is 4 minus 3 is positive 1. I accidentally forgot about that too. So really it would be about right here. It would still be about less than 1. So let me delete that thing that I wrote first. Okay. Now let's write in blue what our original parent function would be. If we know anything about our function, if we plug in points, we know that our square root function has 1, 1. If you plug in 2, it is, or sorry, if you plug in 4, the square root of 4 is 2. So you have 4q as a point, you have 9, 3 as a point. So it's gonna look like that. So whatever we draw will look kind of like that. And it will have a y-intercept right there. No, I shouldn't draw things because I can't undo. Okay, now we're back to, let's just do purple for our new function. So we know that if 0, 0 is our original point, then if we go left 3/2, that's 1.5 here. I don't know if you can see my cursor, but it's right there. And then down 3. That would give us our 0, 0 point right here. So that's where our end point is. And we can do the same thing with 1, 1, 1.5, 1, 2, 3. Oh, sorry, that's not taking into account of the vertical stretch and horizontal compression. When you're graphing, you don't really have to do that for the purpose of this concept. But what you really would do is multiply our y value by 2 and divide our x value by 2. But let's not do that for this purpose. But we know that it would look about like this with our horizontal compression, horizontal compression and vertical stretch. And so that's what you would do to graph that one. Okay, so that one took a long time to do, so I'm not going to do this one. This one I'm not going to spend as much time on. But I'm going to go ahead and, this is luckily for time's sake, this is already in standard transformation form. So I'll do the transformations, and this I'm going to do it quick this time. So the negative means reflection over x. Hey, what did we forget? This was supposed to have reflection over the y-axis. So that means that actually, or sorry, reflection over x-axis. So actually, it's like this. That point just swaps and goes up here instead. Okay. So ignore the first purple. I'll just make this in green. And it's not very good. So sorry about that. Forgot about that one. So this time we're not going to forget. Okay. Reflection over x-axis. The 3 means vertical stretch of 3. No, there's nothing for b. That means right 2, negative, and up 2, or up 1, sorry. And we can already know that if we plugged in 0 for x, what would our y-intercept? 0 minus 2, negative 2. Negative 2 squared, 4. 4 times negative 3, negative 12. Plus 1, negative 11. So y-intercept right here. And then our parent function would be y equals x squared. That's our quadratic. And it would look about like that. That's definitely not even. And I'm not going to draw it completely to scale or whatever you call it. But right 2, up 1, be right here. But since we have a reflection over the x-axis, it's going to be like this. And there you go. That is this lesson. It was a long lesson, and that's probably just because I was doing this PowerPoint thing. I still might do that for the next video, but maybe I'll try to make it to where I don't have to draw. So thank you for watching this new kind of video. Sorry that it was long. I don't know how long, but long, I bet. So that'll be it for this video, and I'll see you on the next one.